When gas and dust spiral into a black hole, the material crowds together. This creates enormous friction and pressure right at the edge of the event horizon. As matter accelerates near the speed of light, the sheer energy acts like a slingshot. It flings hot, fast-moving material back out into space. This gives us a basic rule of astrophysics. If a black hole is actively feeding on matter, it has to blow a wind. Sagittarius A star, the 4 million solar mass black hole sitting at the center of the Milky Way, is actively pulling in molecular gas. Yet astronomers couldn't detect any outward blowback. It appeared to be consuming material in a perfect vacuum without producing an exhaust. For decades, this data gap frustrated physicists trying to map exactly how galaxies evolve. The central problem was our vantage point. To observe our own black hole, Earth's position requires us to look directly through the flat, densest part of the Milky Way. Between Earth and Sagittarius A star lies 26,000 light-years of thick dust, ionized structures, and debris. If you point a standard optical telescope at this region, the visible light is completely blocked by that cosmic fog. The exhaust remained perfectly camouflaged by our own galaxy, creating a 50-year observational roadblock for astronomers. To bypass the dust, researchers had to abandon visible light and track specific radio and X-ray wavelengths instead. They used the ALMA radio telescope array in Chile to map freezing cold carbon monoxide gas lingering at the galaxy center. By applying a new digital calibration process, the team scrubbed out the blinding radio signals naturally emitting from the black hole itself. This created an incredibly sharp image isolating just the inner 1 parsec, about 3 light-years, immediately surrounding Sagittarius A star. By targeting specific wavelengths and stripping away the background noise, astronomers finally achieved a clean, localized view of the event horizon's immediate neighborhood. When researchers analyzed the data, they didn't see the wind itself. They spotted the perfectly carved void it left behind in the gas cloud. This map reveals a massive 45-degree cone completely devoid of cold molecular gas. The black hole's high-energy heat acts like a cosmic snowplow, violently pushing away cold gas. NASA's Chandra X-ray data confirms bright, hot energy exists exclusively inside this hollowed-out cone. Deducing the shape of the missing cold gas provided the first definitive proof of the invisible wind. The negative space proved the hot exhaust was there. There are other forces that push gas around in space. Researchers had to calculate if the combined normal winds from nearby stars could have carved this cavity instead. The math ruled them out. Hollowing out a region 1 parsec deep requires more energy than all the surrounding stars can produce together. The source had to be the central supermassive black hole. By measuring how far this wind has penetrated into neighboring streams of ionized gas, astrophysicists estimate it has been blowing continuously for at least 20,000 years. Compared to distant galaxies where hyperactive quasars violently erupt, our black hole is emitting a relatively calm, sustained breeze. Sagittarius A star follows the rules of physics just like any other. It simply provides a rare close-up look at the dominant resting phase of a supermassive black hole's natural life cycle.